Consumer theory is about maximizing utility, getting the most satisfaction. Okay. Production theory is about making more, higher output, or lowering costs. Okay. So the goal for the consumer theory is to maximize utility, to maximize your satisfaction. Okay, you are being placed as a consumer who has got a constrained budget and a limited number of goods you can buy. So you want to find out what is the best combination of goods that I can get. Okay. Same with the production theory. You're dealing with labor and capital. Okay. You want to minimize your costs. Okay. And you also want to maximize your output. So you're going to say, what combination of labor and capital should I have so that I maximize output and minimize cost? Okay. These are the goals. Maximize utility, production theory, maximize output or minimize cost for the given output. Okay, these are the functions you see. Okay, if you see a U and something like this, you're dealing with consumer theory. U is just utility, satisfaction. Okay, Q, here the Q is your quantity or your output. You see a Q, the function, that's production theory. Okay. Cobb-Douglas form, as you are going to say, utility function, you usually find it's written like this: U, x to the power, you might have a number here, y to the power, a certain number. Okay. With Q, you're going to, with the production theory, you're going to see L and K. L is for labor, K is for capital. Here in the utility, in the consumer theory, X is good X, Y is good Y, the two goods. Okay. Yes, so you usually see functions like this. Sometimes the functions might be different, but most of the times you see the functions like that. Okay, so those are the meanings of the variables. X is good X, Y is good Y. L is labor, K is capital. Okay, this A, I'm going to explain it once we reach production theory, but it talks about, it's a scaling factor to see if you put how much, if you put this certain amount of input, labor and capital, how much will your output grow by? Okay, that's what this A is basically for. So what the exponents mean, have you seen these A, this alpha and beta, and this alpha and beta thing? So for the consumer theory, they show how important each good is. Okay, so for example, if this is like x to the power 0.5 y to the power 0.5, it means both good x and good y are important to you. They're of equal importance. Okay, because the importance, we'll just take it as the total is 1, which is 100%. So this is like 50%, 50%. Okay, so if you see it's x to the power 0.5, y to the power 0.5, both goods are of equal importance. Okay, for the production theory, if you see L to the power 0.5 and K to the power 0.5, it means capital and labor of equal importance to you. Okay, but in a situation, let's say 0.7, this one is 0.3. Labor is of more importance than capital. Okay, labor is of more importance. If you see something like this, because you can see labor 0.7%, capital 0.3. Okay. All right. Next, the constraints. Okay, what basically a constraint is just something that way you are limited. All right. So here with the consumer theory about the budget constraint. All right. The budget constraint, remember, PXX is this basically saying price of X multiplied by quantity of X plus price of Y multiplied by quantity of Y equals your income. Okay, just for example, if you go to ShopRite and let's say you have got a budget of 100 kwacha and you only want to buy, let's say, sugar and tea. Okay, so your I is going to be 500 kwacha. PX is going to be the price of sugar. So if sugar is 50 kwacha, so it will be like this. If your income is 5, what 100 kwacha, that's your income. Good X, let's say it's the T is 50 kwacha, so you say 50x plus the price of the other good is maybe 20 kwacha. You put it like this. Okay, with this equation it shows you to tell you how much of X and Y you can buy with this income. Okay, this is the budget constraint equation. Always remember it, because in the questions you'll be asked to form this one. Okay, this one is now for the cost. Okay, W is the wage rate times quantity of workers plus R is the rate of capital multiplied by quantity of capital and C is the cost. Okay. So with production theory, this will be the one you need to make. Okay, the equation. This is the equation you're going to need to make for production theory. So the meaning of this budget constraint, consumers limited income. For in the production theory, the firm has a limited cost or a budget. Basically, we say budget most of the times. Okay, the firm has a budget, and you can't go above that budget. So you have to find out how much capital and labor you need. stay within the budget. The marginal concept. In the consumer theory, it's marginal utility. Okay, this is the addition. When you hear the word marginal, that is additional. So utility satisfaction. So the additional satisfaction you get when you consume more of one product. Okay, that's what marginal utility is. Okay. For the production theory, it is the marginal product. The additional product you make. Okay, if you hire one more worker or one more unit of capital. Okay, as you can see here, marginal utility, extra satisfaction from one more unit of a good. That is marginal utility. Marginal product, extra output from one more unit of an input, which can be labor or capital. Okay, the slopes for the budget constraint and the cost constraint equations. Okay, and for the the indifference curves and isoquants. For consumer theory, you hear what is called the marginal rate of substitution. This is the trade-off rate. You're trading one good for another. In the production theories, the marginal rate of technical substitution. You are trading labor for capital or vice versa. Also, this is also a trade-off rate. Okay, both of these marginal rates are just trade-off rates. You're exchanging one thing for another. Okay, so marginal rate of substitution. This is the meaning. How much of good Y you must give up to get more of good X while keeping satisfaction the same. Okay, that is the marginal rate of substitution. Marginal rate of technical substitution, how much of one input like capital must be given up to get one more of the another input like labor while keeping output the same. Okay, here we're keeping satisfaction the same, the other side we're keeping output the same. So if you see any of these marginal rates, just know it's a trade-off rate. You're trading off something. In the consumer theory, good X and good Y. Production theory, capital and labor. Okay. So that's for this marginal rate of substitution and marginal rate of technical substitution. Therefore, for the consumer theory indifference curves. Okay, the indifference curve. For the production theories, an isoquant curve. Okay. Did I draw them here? Maybe let me draw them so that yes. Production theory, consumer theory. Okay, for the consumer theory, this is an indifference curve. Basically, it shows the combination of good X and good Y that you can have whilst maintaining the same satisfaction. Okay, colleagues? Combination of good X and good Y that you can have whilst maintaining the same satisfaction. Okay, so for example, if you have 3 units of good y and 1 unit of good x, let's say in this case your satisfaction is 20 utils. Okay, so you can either have 3 units of good y and 1 unit of good x, or if you want, you can have 1 unit of good y and let's say 4 units of good x. Okay, so whether you're at point A or at point B, your satisfaction, your utility is going to be the same. Okay, that's what an indifference curve tells us. Then for production theory, this is an isoquant. The combination of capital and labor that you can have whilst maintaining the same output. Okay, so here output has to stay the same. Okay, so you can have, let's say for example, 10 machines and 1 worker. Okay, this is point A. Then you can also have 2 machines and 12 workers. Okay, whether you're at A or you're at B, you are producing the same output. Okay, isoquant indifference curves. Then important terms to remember: diminishing marginal rate of substitution. It means your trade-off rate is dropping. You're giving up less of y to get more of x. Okay, and here diminishing marginal rate, just know the trade-off rate is dropping. You're giving less, so if it's in the consumer theory, it means you're giving up less of good y to get more of good x. Let me illustrate this here. Okay, there's also a video on this, got a video on this one, the diminished marginal rate of substitution. But yes, let me just try to illustrate here. So this diminished marginal rate of substitution applies also to the same diminishing marginal rate of technical substitution. It's just that in the production theory, what is being given up is capital to get labor. In the consumer theory, what is being given up? Good y in order to get good x. Okay, so actually let me do the diminishing marginal rate of technical substitution, because this one there's already a video for that one. So the diminishing marginal rate of technical substitution, meaning you're giving up less capital to get more workers. Okay, giving up less capital to get more workers. Okay, so let's say, let me put it like this. Okay, so the diminishing marginal rate of technical substitution, we're giving up less capital to get more workers. So if we start from point A here, on our graph here, point A, move from point A to point B, it means we're giving up capital. From 20 machines, we've gone down to 10 machines, meaning we gave up 10 machines in order to get 1 worker, because we're moving from 0 workers to 1 worker. Okay, if we move from point B to point C, Okay, we are now giving up 5 machines, from 10 to 5 machines. So we've given up 5 machines in order to get another worker. Okay, when we move from point C to point D, we've given up now from 5 to 3 machines. We've given up 2 machines to get another worker. Okay, so you can see the trade-off rate is dropping. First 10 workers, 5 workers, then 2. So you're giving up less capital to get more labor. That is the diminishing marginal rate of technical substitution. Okay, and we will apply that to, so you can also apply it to consumer theory. It's just that now it's good Y and good X. So this point, which is called the optimal point of utility maximization, okay, remember this point here. The marginal utility of good X equals over the price of good X equals marginal utility of Y over the price of good Y. This is the point where you maximize utility. You maximize satisfaction. Okay, you maximize satisfaction. Okay. Why isn't, yes, optimal. This is where you maximize satisfaction. It's basically saying the extra satisfaction per unit of money is equal for both goods. Okay, so here you are seeing a measuring extra satisfaction in terms of money, of the money that you are paying. Okay, basically you want to get the most satisfaction out of your money. Okay, so when the extra satisfaction per unit of money is equal for both goods, good Y and good X, that's where you maximize utility. That's where you get the most satisfaction. Okay, where each good that you get, the satisfaction you are getting for each quarter you pay is, if the satisfaction you're getting for each quarter that you pay is equal for both goods, then that's the best condition. It shouldn't be better for one good or the other. Okay, your satisfaction per one quarter that you spend. Okay, that's be equal. That's when you get the most satisfaction. Okay, even with the production theory. Now this is the point of cost minimization. Okay, point of cost minimization. Okay, the extra output per unit of money is equal for both inputs, which is capital and labor. Okay, so when for each quarter that you're paying, the extra output for capital and labor is equal, that's when you minimize costs. Okay, so these two, remember these two terms. This in a question where they ask you find at what point does they ask how much of good A and good B or good X or good Y does a consumer have to get the most satisfaction, you come straight to this. Or if the question asks how much labor and capital must a company get to get the most output or minimize cost, you use this one here. Okay. Yes. Uh-huh.
Mr. Maba, are you going to share this? Because I've just joined right now,
Yes,
so
yes, yes. I'm recording
I'm a
and I'll
bit late.
share this. I'm recording and I'll share this.
Yes.
Don't worry.
All right.
Okay. So the slope of the budget constraint line and the cost constraint is this one. Okay. Earlier on, those ones for the marginal rate of substitution, those are the slopes for the indifference curves. Okay, those are the slopes for the indifference curves. Okay. Now the slope for the budget constraint line, because the budget constraint line is like this. It's a downward sloping line. Okay. Yes, it's a downward sloping line with the price of good Y here. Oh, you've got good Y here and also good X here. Okay. So both this is also just the same as, it's telling the same thing as the marginal rate of substitution. That's why you will see in other books it's written like this: marginal rate of substitution equals this. Okay. So this slope, just as the marginal rate of substitution was telling us how many units of good Y you must give up to buy one more unit of good X based on market prices. Okay. Then for the production theory, marginal rate of technical why are these letters going down? Marginal rate of technical substitution equals this. How much capital firm must give up to use one more unit of labor? Okay. So remember, this is how it starts like this. First you say MRS equals PX over PY. Then remember, MRX is marginal utility of X over marginal utility of Y equals PX over PY. Okay. This marginal rate of substitution becomes this. Okay. Yes. Then when you equate this, that's how you now come to this one. Have you seen here? What has just happened here is this PX goes down here and this MUY goes up there. We just switch spots. Okay. Then for the production theory, we said MRTS equals W over R. The marginal rate of substitution is the marginal product of labor over the marginal product of capital, MPK, equals W over R. Okay. W over R. Graphically, colleagues, what we are saying here graphically is this. For the budget constraint equation, for the consumer theory, I mean, your budget constraint line will be like this. Budget constraint line. Then your indifference curve, where it touches the budget constraint line, where these two meet, that gives you the quantity of good Y you need to get and the quantity of good X you need to get. So for example, if it's 2 here and 3, where the indifference curve IC touches the budget constraint BC, this gives you the optimum bundle, the best combination of the goods that will give you the most satisfaction. Similar with the isoquant and the cost minimization. The isoquant is here. The isoquant here. The cost minimization constraint equation is there. Where these two meet, it tells you how much capital and labor you need to have to get the most output. That's what these things are meaning graphically. Yes. So basically what I was drawing there, those is this tangency condition. Okay, colleagues, that's these small diagrams I drew here. These are the tangency conditions. When we say tangent, we mean the line and the indifference curve are just touching at one point. That's what we mean tangent. They are touching each other at one point. Okay? This is the tangency condition. Okay? So, simple meaning of the tangency: best bundle is chosen when the trade-off between goods matches the market price. Okay. Then for the production theory, best input mix chosen when the technical trade-off matches the input prices. Yes. Then yeah, basically those are these other points you can read through them. Okay. Read through them, but here are the key questions. The key question in the consumer theory: how do goods produce satisfaction? We did it. Production theory: how do inputs, capital and labor, produce output? Okay. And as I said earlier on, returns to scale. When you see a production function like this one with an AE, that A represents the scaling factor, which tells you how much your output will increase when you increase or decrease your inputs, labor and capital, by certain amounts. Yes. Any